Hi, this is Connor, and I wanted to talk about composition of a function with itself. So I started with this function h of x. I have 9 over 7x as long as x is not equal to 0. I am interested in simplifying h of x. So that means I have h of x. So that means I have h of something, and h of something means that I have 9 over 7 times that something. So if the something that I'm plugging into h is 9 over 7x, that means that 9 over 7x is going to go in that spot. So I want to simplify that. I'm multiplying a fraction by a fraction, so I will go ahead and put a 1 in the denominator for the first fraction. And I'm going to divide the numerator of the first one by 7 and get 1, and divide the denominator of the second one by 7 and get 1. That means that I now have 9 over x. But I remember that a fraction bar is a way to show division. And so that means I have 9 divided by 9 over x. Again, I can put a 1 in the denominator where it's helpful. And I remember that I divide fractions by multiplying the first fraction by the reciprocal of the second fraction. So I can divide the first numerator by 9, divide the second denominator by 9, and I now have x over 1, which is x. So I have just shown that h composed with itself is the function x. So this is what we call the identity function, and it actually, by the way, tells us that h is its own inverse, because if I plug x into h, I get something back out. I take that something, plug it into h again, and I get out what I started with. So h undoes itself. H is its own inverse function. The x not equal to 0 part, I don't know where my 0 went there, just means that if I plug 0 in, I get 9 over 0, which is undefined. So this function is defined this way for every x value that does not equal 0. Okay, here is another example. So I'm trying to find f of x, which means f of x. Be really careful and keep track of your composition symbol versus your multiplication symbol. It's really easy to mix those two up. So read the words, make sure that you've got the right operation that you're using. So in this case, I'm taking f of something, and the function f tells me that I'm taking 4 times that something, and I'm subtracting 3. And so the f that I'm plugging into f is f, so I'm plugging 4x minus 3 in. That means the 4x minus 3 goes in that spot. And this one's a lot easier than the last one. Don't forget to distribute. So I get 16x minus 12 minus 3. So I get 16x minus 15. So f composed with f, let's make that look like a composition symbol, f of x is the new function 16x minus 15. Okay, I'm going to do a little spot check on this, so I'm going to plug a number into this and just see what happens. If you plug 0 or 1 in, your example is more likely to fail on you. So I'm going to go ahead and pick 2 to plug in. So instead of x, I'm going to plug in the number 2. So that means I'm taking f of 2. So that means I'm taking f of 2. But I know that f of 2 is 4 times 2 minus 3. So I have an answer 5. So that means I am taking f of 5. But then I can figure out that f of 5 is 4 times 5 minus 3. So that's 17. So what I found going that direction is I found that f of 2 is 17. On the flip side, f of 2 should be 16 times 2 minus 15, so hopefully that's true. That's supposed to be a little question mark. So that's 32 minus 15, and I got 17. So I found that my 2 different ways of doing it both gave me the same answer. So what I was just trying to illustrate was that when I took 2 and plugged it into f, I got an answer of 5. But then I take the 5 and I plug it into f, and I got an answer of 17. And that's the same thing that I got if I plug 2 into f of f using my equation that I simplified out.